Hello friends, this is another video on IFM distributed module or focused on the output device connecting. On my last video I make for the inputs for digital input, so on today's video I will show you the digital output. Okay, let's see the block diagram. The wiring diagram looks like this one. So here are two output devices. One is the horn and the other is the LED indicators. So the wiring looks like this one. So it's the pin or the port for IFM module is M12. So the wiring looks like this one. 3 is minus and 4 is the controlled signal or the controlled output signal. Likewise, the connection looks like this one. So let's go to the schematic manager. I have already created for the project for the digital input last time, as you know. So I will do for the output here. So let's add. So here is the IFM module, distributed module. So I have added two ports for the reading to digital input for my last video. So I will add two ports for digital output. Okay, I'm searching. So my module is AL1203. So for the digital, this one. For digital, I have to add this. I have to add two ports. Okay, as you see here. Let me change the address. Okay, 30. Also this one is 30. Let's make this one 40. Sorry, 40. Okay, here for the output devices we have to read the status of the port. Also we have to write some data to the output device to control the actuating part. So that's why here it has inputs. On the input side it has an address, and on the output address also it has an address. So let's try to describe more. So okay, here. So these inputs are to read the status of the port. Is the port detected is faulty, or the data data valid? So we have to read this values, the status of port. By reading those variables we will know the status of the port. So here is an output. So this will use it for the controlling the actuating part. If you like, we on our wiring diagram here, the LED is connected like this one. If the pin 4 is high, so it will give a light or red or green as it's connected. Okay, so that's it. So let's go to now. I have using many digital output devices, so I have to create one function to read, and I will use that for all ports. Okay. Okay, let's close. Okay, let me add the one function. Let's say function 30. Let's say write to digital output device. Okay, sorry. Okay. Okay, sorry. To save time, let me write my variables in the program. So I will describe or explain detailedly. So I have created the function. So let's try to explain that one. First, let us see the local variables. Here, as you see on my input, I have added 3 variables to read the input starting address, the output starting address, and the port or pin for status. To stop and to stop or to on or to off the LED. So I have to assign one variable here. Okay, on my output, I have to add for the input the port statuses for the pin input 2 and port detected, port faulty, port data valid, or also I want to know the is reading of the block okay or not, and also is writing of the block okay or not. That's why I added those 2 variables. These are for the status of the port. Okay, on my temporary, so I said before, for reading I have to read and write on that port. So that's why for reading I will put my data on the temporary 1 byte as you see here. So I will use those, only I use those 1, and also for writing it's one byte, so it looks like this one. It's from 0 to 7. So I only use the first pin data bit, that's for pin 4. Okay. Here are the starting address, the input starting address, and the output starting address. So I will put the address from the input to on my temporary variable, and here is the variable for storing for error code, and also I have added 1 variable for a temporary or to flash my blocks with there. Or I will show you the usage of this one later. So let's start on my program. On network 1, I will put the input as starting address to the temporary variable on this one. So I will store the address here, so I will use later. So on network 2, I will read the PQI or the status of the port here. So the starting address I will put, as you know, system function port is for reading DB labels. So here I will put the address here on the this one. So one thing I haven't mentioned is that I try to mention the variable where it belongs. Is that on the temporary or in on the input or the output? So I will, if it is on temporary, if it is, or it's come from the output, if it is it is from the input. So that's why I try to distinguish or easily understandable. So I put the address of the input starting address here, and error code is this one if the flow has countered an error. So put the record or the data to the local variable 00, starting 00 1 byte. That means as I said before on my local variables video, I make on this on a video so you can watch. So it will store here. So it will store the data here, starting 00. This one, 1 byte. Okay, so I read it port the port status. So if the reading is okay, if the binary result is 0, that means not the block is not reading. So it will not, it will flash the storage by 0 here. It will move 0 to the fill byte. So I will use this variable to again to fill the local variable here. So as you know, the blocks or system function 21 is copying. So I will put this variable that is filled with 0 and flashes the input, the temporary variable here. So it will, the port status will be all 0. Okay. The other network is port status. So pin 4 will be moved to show onto the output. This one, as you see, this is the temporary. So if you, this value will be here. So it will try to describe or transfer the files from the temporary to the output. I tried to write on the STL because this makes writing easy and saves the network numbers. So I read the status of the port here. So my block will show the status of the port later. Okay. On the 7 network here, I want to parameterize the temporary, this one, to write onto that port. So port, the temporary port, okay, this one, and port pin 4 will be right here from the input. So I'm parameterizing the network, then only this will get value. The others are clean or clear. They are 0. So to on and off, I will use this port pin 4. Sorry, pin 4. So pin 4 will be controlled. The others are always 0. So after I have parameterized the output temporary, so I have to also, I will move the output starting address to the temporary again, this one. So I will use this variable later again. So I use system function 15 to write to that port. So the address is here that get from the input, and it will move the data record from local variable 2.0 1 byte. So that means this one. So when I double click these parameters, I have already parameterized those variables on above network here, this one and this one. Okay. So I will write the value of these variables to the port to actuate or to non-actuate the values. So the error code will be stored here. So the last one is writing of the block okay or not okay. So if the binary result is 1, that means reading is done correctly. If it is 0, writing is not good. Okay, great. I have already created the function, so let's use that one now. So let's use, on my hardware configuration, I have added 2 ports. Let me show you. This one, I've added 2 ports here, so I will use these 2 ports for one for the siren or the horn, the other for the indicator lamp, sorry. Okay. So network 1 for network 1 and the 2 I have already used it for the input reading. Okay, port 3. Siren or the horn control. So the function is 30. So the input starting address is 30 for the input, and for the output also 30. This one. Okay, 30, yeah. For my control pin 4, I will put on some memory 30 0.30. So this memory bit will control the actuating and of the or on of the siren. So to read the status, I will put this one 31, 32, 33, 34, 35, 37, or 6, sorry. So I get the status of the port and the reading of the blocks here. Okay. So I have done for one port, so for the siren. So let's add one for the port 4 for indicator lamp. Okay, again I will call the function the output function. Okay, the starting address is 40 for this one 40.0, that controls the indicator lamp on or off. Starting address one is this one. I'm using port 4. Okay, 1, 2, 3, 1 4 5 6. Okay, so I get the status of that port here, pin port pin 2, and port detected, port faulty, port data valid, and the block status of the input is okay, and the block status of writing is okay. So I have keep all that port data here. So I have done for digital output. As you see, I have added two ports or two digital outputs, and I have created one function 30, to read to write to read and write data on that port. So I used that function for all my ports. If I have many digital output devices, I will use this one function, so it will save time, as you know. Okay, I have done creating for the digital. Thank you for watching. See you for the next part. I will show you for the test of valve module. Until then, have a nice time.